In example 8 and on page 157, we are told that the discrete random variable x has a cumulative distribution function fx defined by x plus k over 8. And we also told that x is equals to 1, 2, and 3. The first step is find the value of k. Find the value of k. This question has 4 steps. It has part A all the way to part D. If we are supposed to find the value of k, basically what we have understood from the previous example is the cumulative distribution of the very last value or the very last possible occurrence will always give us 1 because it is cumulatively added up. That means 3 is the last one, the last entry or the last value in our table. Were we to draw a table, we will come up with 1 here. The cumulative distribution function of 3, which is given by the value of x is 3. You can see f3x3 plus k over 8. This one must give us a 1 because it's the last entry. Then it must give us a 1. This means therefore 3 plus k 3 plus k is 8, and k is 8 minus 3, which is a 5. That is part A. The value of k is 5. What about the value of B? The value of B is asking us draw the distribution table. Draw the distribution table for the cumulative distribution function. Of course, having said that, we must now get the table up. We are supposed to draw the distribution table for the cumulative distribution function. Fine, we have to have the f1 in the table. The f1 is 1 because of x is 1 plus 5 over 8, which is 6 over 8, which is basically 3 over 4. What about f2? What about f2? f2 is 2 plus 5 over 8, which is 7 over 8. And of course, these are the values that we need to see in the cumulative distribution table. So let's have it here now. When we have the x, we have to have the x there and fx. When x is 1, what is fx? 3 over 4. When x is 2, what is fx? 7 over 8. When we have x3, what is fx? Fx is equals to 1. Is simply equals to 1. And that is simply the cumulative distribution function table. Part C, write down f2.6. Part C, I don't want to rub that table, we are getting back there. Write down f2.6. You realize that f2.6 means that this means it simply means the probability of x being equals 2.6, and we are going to be equals 2.6 or less than or equals to. And at this particular point, we need to be very careful because our data is not continuous data. As you can see, x does not take any values between 2 and 3 because our data is very discrete. We have 1, 2, and 3. We do not have anything less than anything between 3 and between 2 and 3, or rather in decimals, because 2.6 captures continuous data, and our question is entirely discussing about discrete data. So f 2.6 is equals to f2 because we cannot go beyond 2 because we don't reach 3, then it's the same as f2. That means what? X is discrete, and therefore f2 is 3/4 plus this is 3/4. No, because we have the table of the distribution function is already here, then f2 is obviously 7.8. In other words, I wanted you to just understand that this one is taking us to continuous data, and we don't have continuous data in our table. We are entirely dealing with discrete data in our question, and f2.6 is the same as f2 because 0.6 now it's something that is not shown anywhere in our question. Let's talk about part D. Part D of the question is find the probability distribution of x. Find the probability distribution of x. The probability distribution. Of course, it goes without saying that the probability, if we produce our table, the probability of x is equals to x. The probability of 1 will remain 3/4, simply because even when it was cumulative distribution function, it was only standing alone and it was not added to something else. But it is the probability of 2 that we have to have 7/8 minus 3/4, because remember f2 is the same as probability of 1 plus the probability of 2, but the probability of 1 f2 is 7/8, which is equals to 3/4 plus the probability of 2, because we are going to add them cumulatively. What does this mean? That the probability of 2 is 7/8 minus 3/4, the LCM being 8, 7 minus 6, which is 1/8. So the probability of 2 is simply 1/8. And that's where we are. What about the probability of 3? The probability of 3 is 1 minus all this, because now we know the f3, which is 1, is given by the probability of 1 plus the probability of 2 plus the probability of 3. And we can have all this. This means the 1 is equals to 3/4 plus 1/8 plus the probability of 3, which is not known. So if you are to make the probability of 3 the subject of the formula, it's going to be 1 minus 3/4 minus 1/8. This is all going to be under 8, and this is 8 minus 6. 8 minus 6 minus 1. This is 8 minus 6, 2 minus 1. You're going to get 1/8. So the probability of 3 is itself 1/8. Please note that the cumulative distribution function fx is not as the same as probability of each and every individual. The probabilities cumulatively added together, they are the ones which make the cumulative distribution function. So please differentiate between distribution, cumulative distribution function and the probability distribution of each and every entry. All right?